So yeah, attention. Okay, so now you have done is loaded the file. Great, first step is done. You have just loaded the file. If you see the mapping, this is the first thing that you do, right? If you see the diagram, we'll follow the flowchart and you should also do the same. The first thing is data gathering. That is what we have done now. Okay, let's come to the next stage. Okay, so now you want to know more about the data. What is the first thing that you do? Train data.shape. Right? It will tell you that okay, train data has 891 rows and 12 columns. Right? Now what you want to do? You want to see more about the contents of the data. How much data is present there? Right? What are you doing? Train data.info. Okay, it is telling you that 891 columns, but some columns are missing. Some column has null data in it. Right? Like each column has null data in it. Like cabin column has some null data in it. Embarked also has 2 null data in it. What is embark? Now let's understand the meaning. Passenger ID is ID of the passenger. Survived, it is the case, it is yes or no, whether the passenger survived or didn't survive. Then you have P class, passenger class. Okay, class 1, class 2, class 3. Name is there. Okay, sex is there. Then his age is there. Siblings information is there. Parental something like that, parental relationship or something. Okay, some numbers. These are telling you how many siblings are there, how many kids are there, how many parents. I mean, is the parents there or not? So some information like that. Then you have ticket information, fare information, cabin information, and embark information. Embark is did they get onto the ship or not? Okay. Now, okay. Now you want to find out. Yeah, what happened? Sure. Okay, let's see. Okay, so now what you want to do? You want to find out. Okay, you want to find out. Both same folds. The general place in the stock. From the Okay, so the next thing that you do, you want to find out which are the null entities in it, right? You execute this when you see this code. So what is this telling? Is null sum. For each column, it is telling you how much null entities are there. right? I'll write a comment also here. Tells how much null entries are there in each column. Okay. So here you can see that KBN column has a lot of missing data, and if you're trying to process something on missing data, you might get into situation that means it might throw you an error and all that. So you should always be should always be the first thing that you should be doing. Yeah. Okay. Okay. So now the next step is doing a describe. A describe really tells you some mean or whatever numbers are there, right? It tells you a little bit more about how much. So you can see here that mean survived is mean one survived is really 33, 38%. Okay. Okay. So now until now it is clear. Okay. When you get the data, this is the first thing you should be doing to know more about the data. Huh? Which one? This one is null. How much null entries are there in each column? That is what this told you. Okay, here what you're seeing here, you're seeing here that these, if whenever you're seeing integer, this is an integer column. Whenever you see object, these are object columns, right? Okay, then so now next thing is some columns you don't need, you want to delete it, right? So you choose to delete your KBN column because anyway that is a string. Okay, so now you want to see age distribution of various data. So that's what you did. You enable this plotting information here. Okay, and this is what you're doing. You're plotting the histogram based on age, right? 0 to 80 is the people, and you can see a lot of people are in this age bracket. Okay, and you can see one thing that you did, drop NA. Can you execute this line now? Now reach here, write this code, these two lines.
It's roughly will drop number list, right? Before it drops.
Yeah, so that is what drop NA. If you try to remove drop NA and do it, it will throw the error. Okay, so you need to drop first, then only you can plot this graph.
But if it is manipulated, then what we need to do?
Huh? No, for you're not dropping it from the entire column, entire data. You're just dropping it so that you can show this curve.
ZekeLabs, what is this? Percentage humidity.
This one, this line is telling it that you have to show the graph in this notebook itself. Got it, right? If you don't do it, you have to write plot plt.show.
Is it dot inline or underscore?
No. Space. Okay, so what is this line doing? This line is trying to drop NA rows of age and show fine, right? It gives you that representation. Okay, this is how the data is like.
What is our goal here?
The goal is to develop a find out whether given you give some data, it will be telling you whether this person lived or survived.
That we can do by using list also.
Using?
We know that there is name or listed over there.
Oh, wait.
It's not this passenger name will be there.
Naming is a different thing. It's
sort of a prediction.
prediction. Yeah, of course, prediction. So you give the passenger details. Name doesn't matter actually. If you give the passenger details, it will tell you whether the passenger would have survived or lived. You can give your age details and all that now. It will tell you would have survived or lived. Understood, right? So we are developing a prediction algorithm here. Okay, we just have training data from the previous list. Based on that, it will predict for us. So we will push here Jack's age, all those things. We will not push Jack name.
Okay.
In the prediction part, we'll push here Jack's age, passenger class, all those things, and we'll see it is telling you that he will be dead. Okay. Is it clear to everybody till now?
So history is what is it?
It will plot histograms. Diagrams. This guy. It will tell you that a lot of these many people are in the 20 bracket. Directly you dot hist, it will show you that histogram here, right? Data frame dot hist.
So the bin size will be automatically taken by the researcher. Bin size, the range.
Bin size default it will take, depending on the data 10 or so it is taking in this case. It will take. Okay. Now, what you want to do is you want to basically get all the rows. Okay. You have to basically get all the rows for which age is mentioned, because you know that age is important. So age needs to be filled up there, right? I mean, whatever missing data is there in age. How can you? So now is a question. Okay. Yeah, come back. Okay. So you have some rows with missing age. Can you predict this missing age?
Yeah, based on ticket.
Ticket.
I think if you on an average we can see.
That is one possible method. Exactly. What you can do is you can find out average of all the people and use that average as filling data, but may not be good compared to what you can do is you can do class-wise average. There are multiple techniques there. Okay, listen to this process. First is what you're right saying. One is you find average of all the people and whatever missing data is there, replace it by average age. Fine. The next approach would be, every passenger, every class has different age, right? Okay. You find out, mean age of every passenger class. Then whatever the class, so it will be more precise. And there is more techniques. You find out, okay, passenger, which area he got embarked into, right? You can use all these techniques. Also, you can use linear regression to predict age, right? So that's what I'm saying. So for filling missing data, also you can use algorithm. But remember, if this is one of the process, right? So first thing that we'll do, we'll try to fill the missing age using linear regression. So this is the problem, which is classification, but we'll be using regression also in it, so that we can fill up some data, right? That will be the solution. Regression, classification to independent theoretical subject, but if you're solving a business problem, you need to see how can you use them and provide a solution. Understood what you're supposed to do now? Okay, I can do the basic things. I'm not doing that. I'm taking the linear regression case. Fine with everybody? So we'll use linear regression to predict the missing age.
One more thing is like in standard that group by user, right? We can use that to fill up the previous data.
You can do that. Missing
like
backfill, forward fill.
In the class end.
You can do that. I mean, if you're grouping it based on passenger class, you can do that. Note down this as an assignment. Okay. So what I have to do, this approach will do. Okay, you have to fill the missing data. Okay. You have to find mean age of each passenger class. right? Then fill any passenger age is missing in that passenger class, fill it with this age. Okay, so let's now get to that there. So okay, so let me insert new rows. So what we want to do, we want to first use the rows in the training data, right? The training data will be the rows which has age present. From that we'll create a model. Oh, okay, then we'll see what is accuracy. I mean, actually we can divide that into two parts: training data and testing data. Whatever the information we find out, we can use it with other missing data to find the missing age. This is the process. Let's do that first. Predict missing age. Okay, having said that, remember this may not be the best process. We may not get the best of the result, right? But the objective here is to learn the possibilities. Using okay, so first let's get yeah, this is getting it right. If I execute this line, it will be valid age data, right? Okay, see what is it? This will return you what? True, false, right? See this is getting true, false. So wherever the age is missing, it will be false. If you pass this Boolean array to training data, what will you get? You get the only the data which has age present in it. Okay. Only data which has age present in it. Okay, so we can see we are getting all the data which has this stuff. Okay, so now what we want to do is we want to wait. Okay, and this is how we should wait. Good, carry on.
Avanti. Hello. Hello. Could you able to result? Hello.
Okay, you can see how do you write this train data dot age. This is a column name, not null. It will give you true and false for whatever data it is present here. Shortcut keys for getting all the function is .tab. Okay, now these are the columns that you're interested in picking up. Survived, passenger, class, sex, sibling, I think parent information, embarked, and age. Right? So you're picking up all these columns here. Right? Because name anyway doesn't matter. Ticket name also doesn't matter, isn't it? It's just a number, right? It really doesn't have. Fare is an useful information though. Oh, I have not used fare, right? You should use fare.
It can be in any order, right?
Yeah, it can be in any order. Fare.
In this case, ticket is same.
And the ticket is ticket number. So I don't think it is an important stuff. Fare is good enough. So I added this. Fine so far. Go to the next stuff. I'll go ahead here. Okay, then what is the next thing you have to do? You have to break the data into two parts. Age data into age, train, and test. Right? You have to divide the data into two parts. Okay, so how do you divide the data into two parts? From from skill and model selection import.
I have tried to do models.
Train test split, yeah. Okay, so this is the library you have to import to split the data into two parts. Okay, below train test split, you pass here. What do you have to predict? You have to predict the age, right? In this case, you pass here.
Internally to be split.
Yeah, we want it to split actually. Okay. Okay, so I'm just splitting it in one shot, to make it simple. So you have this age X, right? It is only the feature data.
Here, this splitting. Here we are just model selection importing train test dot split. It's just importing. That's all.
Right, that's important. I will use it.
Still, we are not
splitting it. Right. API. This is the feature data, right?
Yeah.
This is the target data. Age underscore y. Age. Find this line, these two lines. One is target, one is this. Okay, so now you use train test split age X comma age Y. It will divide the data into 4 parts. Age train X, age train Y. Test X. Age train X. Okay. Age train Y. Also, sorry, root tables. Test X. Chain X. Okay, so what happened here? See this line. It divided the data into 4 parts. This is your train X. Train X means feature data, right? Feature data, and this is your train Y. This is the output of train X. Sorry, this is test X. You divide the data into 2 parts. One is train data, one is test data. Train data will have feature data and as well as target data. This is train X feature data. This is train Y target data. This is test X feature data. This is test Y target data. So you have data divided into 4 parts. Is the name clear? X and Y. X is your feature, Y is your target. Fine. This is what happened here. So now what do you want to do? You want to use linear regression. One will be the train test. Using that you will find test and see how good is your algorithm and all that. Let's see.
Here this pattern of a function.
No. Because you don't know which degree of linear regression is fine for you, isn't it? Right? Which degree is fine for you. So you have to use that degree, that linear regression, right? Transformers, those things, whatever we wrote there, right? Okay, try writing it. Okay. So from
Feature data is the data which you manipulated.
feature data is your feature actual feature data. Means your the independent variables. The dependent variable is a feature is an age in this case. You want to use all the other columns to predict the age, isn't it?
So
Okay.
feature data is
Independent. Independent of this passenger class, did he survive or not, all this information. Age as of now. Okay, so I should write it maybe. Feature data. Survival.
We're changing the sales department on to numeric, right? Same way we have to do it.
For a sex column also we have to do the same. Right.
But is this correct way to do? Like predicting age, we are taking all the survived class.
What is wrong? That is data, that is correct.
But what you mentioned was we'll take the average of the current age and
No, that is one technique. This is another technique. So there is never a correct, I mean, you have to find out the correct process. This is one of the process. And the reason I'm using it because this is quite common to see such things.
So how will we find the age?
Linear regression. Right. So we'll use linear regression to find age from this. Okay. Okay, now let's see the content. If you do age train X head, you can see all the information. Age is not there.
This is the split data. Statistics.
Okay, this is the split data. Now what do? You want to train the model, right? You have to find the best way to see that now. No, I haven't.
Can you hear me, Avantik?
No, it's not mute, Sunil.
Okay. Can you hear me now?
Okay, so now what will you do? We'll try to use okay, for that we have to create that function, right, where a degree will change, the same sort of thing. So what will def age regression pass here degree. Okay, return. So From sklearn dot pre-processing. Import
Yeah. Avantik?
okay. So what you did here, you created a polynomial feature. So and then what is the other thing? You have to use pipeline, right? What is in where is pipeline? sklearn. Okay, in case forgetting the package, so what you do is go here, sklearn pipeline. Yeah, it is sklearn pipeline dot pipeline. Yeah, dot pipeline. Make pipeline is there. Make get pipeline, make pipeline. Here I'll be using make pipeline, escape pipeline, make pipeline. Okay. Yeah, make pipeline. So what will you do? You'll do make pipeline. Okay, then you need polynomial features, right? Like this, so that you convert that 1 degree to multiple degrees. So now polynomial features degree and followed by linear regression Is this code clear?
Explain this thing.
See what you did here, you need to do linear regression. This is one of the easiest code of linear regression. You have polynomial features which will convert whatever data you are giving to polynomial features. Like first time we'll do degree 2. So, okay, so one column will be 1, next column will be x, right? Next column will be x square, right? If there is only one feature. If there is two feature, 1 x, x square, y square, xy, right? Okay, that thing it will do. Fine, right?
So in this we have 4, 5, right? 5 just repeat.
It will take 1, 2, 3, 4, 5, 6, 7 features it will take. Male, male, female, all these things it will take. Okay, but prior to this, what we have to do? We have to convert all of them into numbers, isn't it? Okay, let's do that task first. How do you convert all those things into numbers?
Convert dictionary.
So this will take subclass also.
Level encoder we have to do, Label encoder is inside text processing. Label
If dictionary.
Pre-processing, yeah, it is inside pre-processing. sklearn
if a vectorizer, count vectorizer.
Yeah, so we are using level encoders. Right, level encoding because we have fixed number of okay guys, prior to do so, right, do one thing more. You are in this stage, right? Now you have to understand each column, what are the possibilities. So if you want to see how many classes are there, so do this guy, h train. This step is very handy actually. H train x dot dot survived not unique. It will tell you how many unique options are there. Try to do this for all the columns. It will tell you what are the possible options each column have. Okay, do this for, so it will briefly tell you, it will briefly explain you this guy, right? Age check survived unique. Try to do this for column which are age column, not age column, sex column. It will tell you what are the possibilities, male, female, two possibilities it will tell you. So you know that there are two varieties of it. So this is one thing that you should do. Okay, it gives you what are the possible number of classes for each of these stuff.
Age
right. Yes. No, actually, age, apart from age, you should do it for this P class. It will tell you what are the possible passenger classes. Okay, and what are the possible. So if you have huge data, right, this steps is very handy so that you can get a sense of how many possible classes are there.
So now for only one we have to do, for all six we have to do.
Now, what all things from which you think it is categorical in nature? How do you know it is categorical in nature? By seeing the info. Wherever you see obj, right, object, that is categorical in nature.
Object is
right. Object is categorical in nature. Now, all those columns which you think is object here, do this step.
So
object column. It will tell you how many possibilities are there.
It means we have to go for test and train.
Together one before we actually split, right? Could have done this. Okay, so that you know what are the all possibilities. But since it is very fairly simple data, so doesn't matter doing it here. But if it is complex data, this is the first thing that you do. So you will understand what are the possibilities here.
Yeah, this is a training phase.
Before training phase, data analysis phase.
Why we have to go for survive? Since it is not an object, right? The first one which you have displayed there, it's a numeric thing, so we don't have to do it on those things, right? Only for object kind you have to do.
Object kind you. Object or wherever you feel it is limited. Like here, 1 and 0 is there, it is integer, but it really give you things there is only 1 and 0. Like, I mean, I think you got it right. I mean, you have to make sense of the data. You have to understand the data very well before you can actually feed it for training. This is one of the steps.
But when we give degree, it takes it becomes 7 and it is considered as possibility also.
See, but for doing age 87, it's a continuous rate.
It's not giving much useful information, right? No, just to get a hang of it. This unique thing, right? This is very useful. It will tell you what are the possibilities of data. By seeing that, it became useful to you, right? That this is just an output. This is a regression output.
So that should be done to just analyze the data.
Analyze the data. Okay. So that we know that when I'm about to apply level encoder here, so I'll know that how many possible classes it will convert.
This degree will take only these 7 hours to get some classes of each possibilities of each.
No, which degree? Degree I have not given you. Whatever degree you give, you will try to do all possible combinations.
It will be in the range of degrees.
Possibilities also.
Yeah. Maybe when I show it, it will become more clear if you are missing out something. So now, what you want to do? You want to convert all the new string column or into some number. So we'll use level encoder. From sklearn dot label encoder. Okay. Now we'll use label encoder. Okay, label encoder for each categorical column. So what are the options column that we need to take care? One is this column, and one is embarked column. Right? These are the two columns we need to take care. Okay.
Previously, you said this changing this characters to numbers.
There are many techniques, right? Right. One, we used one hot vector, or the one which will convert multiple columns. Right? This is one technique, label encoder. Right. I mean, multiple techniques are there. So the label encoder is useful when you have the male, female, one or zero only come.
Only Boolean. Yes,
Boolean, yeah. Boolean or 3-4 states.
For example, India
25, yeah, 25, 0 to 25 will generate. So it is label encoder quite useful actually. You see the output, it will be clear. Okay, say if I pass it, LE is equal to label encoder. Okay, then we do LE.fit transform. You give here a column name, age Titanic. Age Titanic. What is the column name? See here, it converted into zeros and ones, right? Right. But what you want to do? You want to put it in that column name. Back to that column. Either you can write it in a loop format. For whatever column you have, you execute this code. No, you cannot pass here. So if you have to do it in a loop format, I'll tell you what to do. So, but that's okay. We'll do it in some other example. Okay, just first see this case. So what you can do, we just want to replace one column here. If you have to replace a lot of columns, right? You can write I can show you how you can write a very small crisp code which like will change for all the columns. I think I have it somewhere. Okay, if you want, I can show it. See this. I'll show it. I'll upload it here. Okay, this is one company's data. Okay. See this stuff. This is like it was huge data. It's got a lot of complex things actually. Like lead, it has to identify which particular lead method was good. Okay, so here like it has all this data. Okay, so here using this unique technique, we found out what are the possibilities. Got it, right? See this case, and you after using this unique technique, we found out what are the possibilities. Okay, then I cannot upload the data because where I can
just put a control plus.
What? Okay, see these unique columns. It is telling you this is some real original data. Okay.
Avantik.
See all these things you are getting. After that, what you are doing here, you want to find out basically what you want to do. You want to convert for level encoding from all the string columns. Okay. See this. See, this is the code. This is the columns that you are interested in converting strings to numbers, and you want to use label encoder for all of them. Okay, that is for column in categorical columns. This is your categorical columns. Label encoder, you are writing the column name. You are reading. So in one shot, you will be changing the entire data's content.
Selected campaign data. Selected campaign data.
Yeah.
That is the original data set.
That is the original data set
So
actually
for that column, you replace this.
in this column. Okay, this is how you write. I mean, you don't write for each column. You find out the columns in one shot. You will do all the changes.
The left side can be only one column in that.
Huh?
Feature campaign.
That is one column. Yeah. You
No,
one
but
column.
we have declared the above.
This is the columns actually. So one time it will loop through this, one time for this, one time for this. Okay, got it right? How to do it?
Screen setting after seeing that screen.
Yes. Even mine also.
Oh, that's how eyes work, huh? Okay, understood, right? So that's why in this we have only one data, so I'll not write those sort of stuffs here. What I can do is I can simply age.
That means we have to get the main file, main variable, like age underscore data.
So there is one mistake that we did here. Okay, I should have done this first actually.
I think we have to do it the initial stage.
Because we have already splitted the data. Okay, so this is what you should do actually. It should be happened earlier. But for simplicity, I'm just wrapping it up here.
So we can change the now also, right? Age underscore data.
But we have to again split it.
No, we can copy the score and put it in the front.
I mean, that is possible. We should ideally do these things at before splitting. Okay, before splitting, you should do all the things like data transformation and all that. Excellent. Yeah, that's a problem. I got lost. That's okay. Let me continue. Just follow this point. Okay. Where did I write it? Yeah, here it is. Right. Just what will I do? I'll just in this data age. Okay, age chain. What is this? This is but here embarked. See, one data is missing here. Hello. अच्छा ठीक है Now
from SKLEARN dot
okay.
reprocess and
embark is there. Okay.
From SKLEARN pipeline import make pipeline.
Now embark is also one column, right, which you need to change.
Linear regression. Def age regression 3. Return make
See this error. This is love this error. Okay, str. See when it is telling you str greater than float. You know why this error comes? This error comes when there is some data which is not what you expect. That means there is some okay, so here that is because there is one missing element here, one wrong value. That is what is causing this guy. Okay, that is what is happening. So how to do
So before this, we have to fill that.
either you fill it, and that is what we will do since it is only one value. Okay, so I'm not dropping it. Okay, so okay, how do you know which row it is? What is the non-null is it is, right?
Yes.
We can do a forward fill. Okay, or fill NA we can fill as, or first we want to see what is in majority. Like if I do this root mbug, it is telling me that there is C. If I do this, right, you can see S is in majority, right?
Yes.
So what do you want? You want to replace the missing element by S.
And null values is that then you're transforming it, that time it gives this error.
Yeah. Now it's gone, right? Okay. Understood it? Why would you get that? Remember that error. That is something that that is right. So there was a missing data there.
In a bar.
Yeah. In bar, right. One row was missing.
But we have removed everything.
On the age. At least I have removed only for age. On that drop NA, we're doing it. We are not making the changes there. Right? It is just a return. So now it has all the things which is pretty much in place. Okay, it has chain X. So
what did you do? Just mitigate it?
Huh?
What did you do?
I just replaced. There was only one missing data that was replaced. So we did a group by which told you that S is in majority. So all the missing element I replaced by S. So this is what told me that S is in abundance. So I replaced the missing element by S.
That is perfect.
Right. Okay, maybe I can. Why is it so warning? It never used to show before. Huh? That's okay. I mean, it's there is some setting with it never used to come before. See what has changed in the latest release.
Is that a problem or?
No, it should be fine. Fine, just a warning. Okay.
May increase the font size. Yeah, that will what you see error or what?
No, just warning. I'm gonna change something. So what has happened so far? Okay, I'm uploading the same file. Okay, till this point. Okay, when taking a 15 minutes break. So before that, people who have not reached till this point, just try to load this file. It will work. I'm uploading the same file there. Okay, this is project 6 in the repository. Okay. Reach till this point. Okay, reach till this point. Okay, everybody is reached. Yeah, same. So it's letting go and they're seeing it.
Two values are not there. This is good.
No, I thought it was fixed.
No, it was they were doing some shooting and all that.
Shooting.
Oh my god.
Pull down. Yes.
Even I thought that.
Sunless.
It is green, sun is green.
Prediction.
So it will fill all this thing. It was too embarked was a mistake.
Okay, so we have now. Let's see the final data frame. That is how it looks like. Okay, this is uploaded now. Okay, age. Right, this is how it looks like now.
Yeah. You have dropped this thing above where it is null.
No, we have filled right.
Something again drop NA.
No. After 46, it is not. I'm not considering that. Just
Okay. Salah? Huh? Still is it pink color on the
Now it's okay.
Hey.
Cara, put your first internet.
Mana? Intentional. So చెప్పేసి it's your responsibility. Is it?
అందుకే నాపుతున్నారు అక్కడికి వెళ్ళారు.
Avantik, can you hear me now?
level encoding చేసి ముందు level encoding చేసి మొత్తం సెక్స్ మొత్తాన్ని నెంబర్స్ లో మార్చాడు
అంతే జస్ట్ ఎంబార్క్ ని మార్చే ముందు
ఇక్కడ
ఫిల్ చేసేది అంతే. సూపర్, యు ఆర్ ఇన్ లైన్. కాసేపు పాస్వర్డ్
Where is my son? Hello. Hello.
Hello. Hello.
Hello. Avantik. Hello, Avantik. ನಂಗೆ ಇದು hello Avantik.
You always
Any doubts? Only one doubt. Start from scratch.
అది కాదు ఈజీ అండి ఇదంతే
बस इतना ही है. अरे बाबा कुछ कुछ हाफ एन అవర్ ఎందుకు 1 అవర్ 9 to 12 9 to 1 స్వామి
9 to 12 పెట్టాడు మిస్
ఏమో ఆమె అడిగింది 9 to 12 అని అవును అన్నాడు 9 నుంచే అని చెప్పాడు కానీ 12 కాదా అని చెప్పాడు ఎవరు ఆయన లావు ఉంటాడు ఆడు కూర్చున్నాడు ఆయన గ్రేట్
Okay, so what we saw is we have a data which is in this format now, right? Now
Avantik?
okay, train x dot header insert.
Some problem with this.
Make it a little more cooler. I think it got hot. Oh, 28. Okay. 22. Yeah. So now, what we want to do? This is my.
So we have done for only training data only the filling gaps and all that.
Those things. So that
Test also we have to do the same test, right? Otherwise it will not work.
It will not work, right? We have to do repeat the same stuffs. Or before splitting it up into, you should have done actually.
So that
Okay.
it will
be there in both. We did not do that, but we just shifting the code to the right area. That's okay. So let's anyway. Okay, let's now create our model. So for degree in I'm just randomly giving some numbers. Okay.
7 or that.
Model degree. This will create the model, isn't it? Now, okay. So this is we are using polynomial transformation because we are doing a regression here. And we have all the data in numerical format, and I want to use degree 2, degree 3 and all that to do the stuffs. Okay. Fit age train X, right? This is train X data. Age train Y. Oh, did I give it too much? It's taking decent amount of time, right? Now we want to find what is the accuracy of each model. Y red is equal to okay, for finding accuracy from sklearn dot matrices import R2 underscore 4, right? Okay, R2 underscore 4. First is the actual prediction or wide true?
Some metrics what we imported
So I am print. Huh?
from sklearn.matrix.
We are importing R2 score. What is R2 score? R2 score gives you how good is your regression between 0 and 1. See, your accuracy is increasing, right? Oh, after 7 it started decreasing also.
6.8.
Right. And after 8 it is 2, 3, 1, 2, 3, 5 is pretty good. So you can try 6 also. 7 and 8 anyway, it's deteriorating.
Can you print for this degree?
68. That is nothing, but you can print it like this. So 6 is doing decent as of now, right? Okay, I mean we can live with that, not that bad. 6, right? Now, okay, so we know that we have to use model 6. Models, all right. You of course can save the model also in an array. This is for saving all the model. It's not that this is the only way to write the code, but okay, so it is saving in the models variable. Okay, now what we want to do, we want to predict age using this model stuff, right?
Yes.
This is what you are doing to import the matrix, to import matrices. Okay, now we want all the rows for which age was missing, isn't it now? Find all the rows for which, in case you're not able to write this with me, I'm just pasting it in the chat window to everybody. And for doing this, I imported okay, now we want all the data which is missing. That was there we were doing earlier, right?
For me, it's a model. I mean, degree 5 is 0.72. I have the order. I have changed it.
Yeah, I mean
the class and survivor.
Yeah, this is no, the odd does not matter. It is the random number which is generated in your case for some data, test data, right? Whatever random
No,
number.
not test data. This is
I mean train data only.
Train data.
Right? The sample of train data that you're using is giving you good results. Okay, that's it. That's why my result will be good. Okay. So now what do you want to do? We want to get all the rows. Train data is there. Train data age is null. I think this is a function, right? Yeah, is null. Invalid age data is coming here. Fine.
we already checked it, right? There's some small math. Yes.
Okay. Now what you have to do? You have to this invalid age data. So if you do invalid age data dot head, it will be all the rows for which age was null, because this is what you have to fill up here. Fine, right? So remember, what is the thing that you have to do?
So we have to do this for age underscore data or like.
Huh?
Not null.
Yeah, because we want all the data which is null here, right? So that is what we want to replace, right?
I'm getting this error where the regression is not defined.
If that is that, what does it mean? It means that you have not imported this file, right?
What is called?
Linear regression.
Linear regression
No. Age regression is this function you have to write. I've uploaded this file in the same place. Just copy paste wherever you're finding problem. Okay. Now what you are getting, we are getting all the rows for which age is missing, right? Okay. Just follow it. Whatever errors you're getting, we'll just debug it in a minute. Huh? Just let me do one thing. Okay. So, right. Whatever is this gender column and the embarked column, right? Okay. So first you do a info of it to see if you are getting anything null. So you can see here embarked column is right. KB is anywhere to be dropped. It is not much of a news, and this age is
dropped still.
I mean, we'll pick up from here actually. Okay. So now let's choose a column that is of our interest. Passenger ID. Do you think it is useful? No, we didn't use it, right? So it will be same columns that we have used earlier. Okay. These are the columns that is of our interest, right? Survived, P class, sex, siblings, pictures, fair, and embarked. Okay. These are the data of our interest. Right. Now, what are the columns that needs conversion here? Basically, this column and embarked column, right? We can copy paste the same code that you have written above. This is embarked.
And then normalization.
Right. Right. Which any doubts so far? Sure.
Briefly. Little. One more. Here we are taking
only the null column. Oh, only the missing columns, right? Because this is not what we have to predict and we have to replace, right?
Okay. Oh, for that only we do okay. Separate data.
Right. Okay, and what is the other column that you have to replace?
Sex.
Yeah. Okay, so let's see the content now. Fine, isn't it? Now, network.
Zoom screen sharing, right?
Other series fine, right? Network issue. Anyway, now let's see. Okay, we have this data. Okay, now what we have the model, right? What is our model? What is our selected model? Our selected, this is the one with 6, right? So how will I store it? Model, say 1, 0, 1, 2, 3. It is in models third, right? 0, 3. Model, yeah, models 3. Third element, right? It is stored here only. Dot predict. Right? What is this? This is your age. Okay. What will you do here? We will. This is the age for all the missing data. Now, see the way now it is actually a little convoluted. Okay, I'll show you what happened has to be ages. This is the ages. Okay, what you got? Your actual, remember, this is what is happening. You had some missing data from in the actual data. You separated that, found these ages for those missing data. You have to come back to original data, replace it there. And imagine now the next phase, right? So what will I do next?
Take that.
Right, let's see the ages. If I do ages, I'm getting all the data here, right? Okay, first thing that you have to do, wherever it is coming less than 0, of course that is not possible. You have to make it to 0, right? There are a few corrections that you are doing here.
So in that case, that matrix we have to check, and how perfectly giving that results we have to check.
Yeah.
It's more less than 0 if it's giving like minus. It's a wrong model which we are selecting.
Yeah, but it can happen. Okay, see, if your age is very less, suppose 1 year, your algorithm is predicting it to be -1. Your algorithm is not doing that bad, but your -1 age is not possible, right?
Yes.
Right. So you'll go there and change it. Understood, right?
Yeah, correct. But what my percentage
is your algorithm not perfect?
No. How much the accuracy it's giving? The is last time MATLAB we have checked the diagonal.
Oh no, that is the classification.
Okay.
Okay.
Not for the age.
For age, it is, we saw, right, 72% you are getting in your case. So you are getting around 72% correct age. Okay, that is what it means. Now, of course, I see some missing, some negative values. I've not seen this earlier. Maybe something is not right, but it can happen. So what will you do in this case? You will try to replace the negative values with 0. But we'll not do it now. We'll first add it to the right position there. Okay.
Before it should be rounded, right? This value.
No, there is 4.4. Yeah, that will let it take care of itself. Okay, but my point is, how do I add it to the specific positions? right? Because huh?
Based on index column.
Based on index column, so we know this index average. This data we know, right? We need to add index here. Remember, okay? This is a very good operation. Invalid data age. If I do index, see it is the actual index here. The data which number, right? So what you have to do is you have to create a data frame. Data frame where data is equal to ages and index equal to this. Okay, it creates a data frame. Now this you should be able to concat with the
original data frame.
Yeah, you should be able to concat with this data frame, and this data frame you should be able to concat with the original data frame as well, right?
Yes.
Yeah. What is my original data frame name?
Age underscore data.
Age underscore data, right?
This where is it?
So,
but from here we have removed this one.
Oh no, we want that original one.
First one. 5 is there.
No, 5 is not there actually. Original one.
No, here age underscore data is not having fifth row.
Fifth row, right? We want actual original one where that missing column row is also there, so that it replaces there, right? It is actually
Train
data, yeah. What is this type of stacking known as? And this stacking. This is vertical. This is horizontal stacking, right? This is your horizontal stacking.
Axis.
Yeah. Wait. You can do concat also.
One question. See, the current data set what we have, we have only queried for the records for which the sex value is not, the age value is not. But in this case, if you are trying to compare a train that has more number of records, so how will you compare that?
So it will find the index number for which it is mapping. It is actually merge operation that will do here.
But in this case, the new line, what are you going to add it there?
No, we are not adding any line. He is merging it.
Merging it with the
original data. Only one column he is replacing with the original. I mean the age.
We cannot replace it. We should replace it.
Oh, that's not.
See,
Right.
yeah, I'll show it.
But we are doing it only for test or train here.
No, train.
That means we have to go for test also.
No, that is for next full set. Who has survived?
See,
has survived or not?
This is our data, right?
So,
this was our actual data, right? Which is now that we calculated. Okay, now, and this is our okay, so the operation. Then you do this, you're appending this data. You got two columns, right? Okay, so what you have is ageless data is this. This is age train data which does not have the missing element. Okay, here it is missing element data. Here only the data which is missing element. So you can append it, right? Because the index will be unique. I mean, it will not be repeated. So you have concatenated all the data.
But this data has everything in numbers, right? Like 6 and everything is in numbers. But your original data is in English.
No. This is our intermediate data.
No, the original data is in English, right? Male is for sex. But all this data which you are showing, it is having everything as transform numbers.
No. So we have
we converted, right?
Lost ageless data that is separate array.
No, if you are going to ask the original array, Okay, that original array is having only equation.
We are not I mean merging with that
No, it
all
was definitely added to the original one, right?
original one only.
We will add it. We will add it to the original one. But before that, I mean, there are multiple ways to do it.
No, I'm just confused whether we will be updating the column which we have modified, like section and bar.
Right.
New column, right? We go to merge this.
See, so let's come back where we are now with respect to data. Okay, but where we have is we have. Okay, we are getting this much accuracy. So, okay, where we have is we have the data. Okay,
the original name is train underscore data.
Train underscore data, right?
Before modification.
Okay, so. This is the actual data, right? Yes. Okay, and we did this transformation and all that. Okay, train data is of this data. Okay, and oh, sorry, it's showing me. Oh, this is a.
No, not here. Go
Should I modify the same file?
Yeah.
Okay, where we where is the prediction? Yeah, here it is, right? Age info. So fine, we are here now, right?
Yes.
Okay, so what we want to do is we want to merge this with invalid age data so that we can get rows. Okay, that is the next step. Okay, this is the data. So age info is there and invalid age data is there, right? PD. This is your age, isn't it? This is your age. Okay, of course, I need to give. Oh, here this column didn't had the column name. That's why it is like this, huh? Right. So ideally, we should give column names also here. Let's make it look good. Right, you can see some of the stuff is really bad, right? Oh, strange. Earlier it was not that bad. Something went wrong horribly, right? Okay, so when you add this excess, right, you can see here the age is coming here.
Right, is 900. 900, 6,000.
Yeah, some of these stuffs are not right. Maybe you can because earlier it was all fine, so maybe something was loaded. Okay, so we are in this state here. Actually, this was the result, actual result. Okay, we have to see what actually during the process what went wrong. But in the using the similar stuff, you see the code here using very similar code. Right, this is here a cost array. All these things were there, right? Similar to polynomial regression, fit, train, extrain, y, predict, right? This is all the error technique. So similar stuff. What you get here is this content here. Okay, this is the content so far, right? So now what do you have to do? Now you have to merge it with the rows which has valid rows. Similar as content, right? So for that, what are you doing? Okay, this is the actual content which is which is actual values age data. Append ageless data. That means the final outcome is now combination of these two. Got it, right? The final outcome is now combination of these two. So age is now calculated. Understood the process you did, right? You did it separately, found out all the rows, merged it back. Right? Merged it back. Now you have, after this, right? After this, see the data frame, how it looks like. It has all age values filled up. Getting any doubts till this point? Huh? Not clear. Not till where it is clear. Which bit? See, you understood 2 points, right? One is there is one set data frame which consists of all age values. There is another data frame which we found out. Then what you have to do, right? This is different rows, right? What you will do? Simply data frame append, right? So you have final data frame with 891 rows, which has for all the data age is present. So what you just did, you actually predicted the age, right? You actually predicted the age. Okay. Then what would be the next step? Fine so far. You have a data frame where the ages are predicted. Right? This is how the data frame look like now. Then cabin is of course not needed, so you delete cabin, and your final data frame has embarked missing here. So you see, 2 embarked missing. What will you do? So 2 data is missing. What do you do? Find the majority, replace it. Fill it with a majority. Simple technique actually. It works. No, it doesn't matter much.
But generally, use on data means we need to follow the same structure.
Same structure. I mean, not necessarily always a regression case, but it might be finding the mean of, maybe that will give you better result in this case. Finding the mean of each passenger class and then filling the value with that.
But again, it differs from case to case. Like
absolutely,
it differs. Temperature between 3 different dates means again we need to see before and after. We need to find the mean between this, and we need to.
Yeah. Depends. So that's why you have to try. It's an iterative process. You have to try one thing, see what is the result that is coming. Try another thing, see what is the result that is coming.
Age also you can do mean.
Age also you can do mean. This is one technique. The reason why I introduced this technique is to understand that one problem solution is needed necessarily one solution. You might have to do this thing, that thing, sometimes unsupervised algorithm, sometimes supervised algorithm, combine the results out of it. So it's an iterative process. So it's not the case you do one thing, there is only one way to do one thing. Last time I did some other way, this time I'm trying to do some other way. Because I don't remember, of course. Okay, that's not what you'll remember. You'll try all the approaches. Maybe last time what I did first, it clicked. Whatever I'm doing for now, it is not clicking. So what you'll do, I'll try some other approaches. Right? Last time I think I took only 2 factors into consideration in finding the age. Now I used all the variables. That is why it is getting screwed up. Got it, right? So it is that iterative process. That means you cannot say that you can solve a problem in 2 hours.
So how the estimates we should do?
How much time it will take? You generally have months of, I mean, not for simple problem like this, but
let's say this is a simple example when you are going online or so you need estimates to the
how much time will it take? So the thing is, what you see, this is this is a process. That's why I keep on emphasizing from beginning. This is a process, right? There is no shortcut. So what you will tell them that boss, I can pretty much find out the pipeline and all that, but fine tuning will take some time. Okay, you can do a lot of combination possible in one run it, then it will take.
Because at last you can come to know whether it's best model or not.
Of course, had it been easy, then of course.
No, generally it's blind and it won't be that much easy. So it's a normal data existing like this one. So it's taking how much time?
No, exactly. So whatever example I was showing you before, right? There was one I showed, like, where is that? campaign. These are company data only. So okay, this was one analysis that we're doing in. So there will be this is I was doing live in the class there.
Okay.
We did almost few things, and after that we realized the accuracy is not coming good. So it's, you cannot say that you cannot finish in one day, right? You definitely I should have done that. Maybe this problem statement is not suited, right? So we wrote a lot of code here, but it didn't work out. It was not a production.
Which you are doing is called data science.
This is data science. This entire process, you're applying data science and machine learning, then you're coming back, finding them. So that's why I keep emphasizing this is a process. If you're engineers, you're doing this. Okay. For this, you need more engineering skills. What are we good at? Right? We know, we know what we are good at. If something doesn't work, we can tweak it, see why that is working. We are good at observation. Right? Most of the bug fixing that we do. Right, that is most of observation thing, right? You observe, okay, this is not fine, then let me try this and do this. So the same skills is needed. Okay. Patience.
Patience is
Absolutely. I mean, sit with it. I mean, that's the reason I wanted to say, sit on it for a day. Solve one problem in a day at least. Sit on it. So after this is done, what is the next thing that we do? We are getting into classification case, right? Okay, so what is the data that you have? You have data with all the columns as numbers, right? And you have find age column is completely filled up.
Flowchart.
Huh? Flowchart, right? Good. Data cleaning is done. You did linear regression. You came here. See the flowchart now is screwed up. You came here, did linear regression to do data cleaning option. Okay, then you are here. Okay, then what is the next thing you will do? You identify whether this is a classification case or this is a regression case. So tell me, is it a classification case or a regression case?
Finally, it's a classification.
Finally, classification, right? We have all the data ready now for us. Right, so we have done with this part. Data analysis, visualization, featureization, all this. So now, classification, supervised came here, classification. So you have quite a few algorithms now. Right, you have quite a few algorithms now. Okay, so I mean, here what we did, we just simply directly applied logistic regression. What you will do, what are the classification algorithms you know so far? Logistic regression is one, naive Bayes is one, multinomial naive Bayes is there, right? Then your nearest neighbor, although we didn't explain, but you know how to use it. The API is the same, right? Fit, predict, accuracy metrics like this. Here you're doing fit, predict, and at the end you're doing it like this, accuracy score. It will tell you how good is your accuracy. Can you do this tomorrow by today? This will boost confidence like anything. This is the only thing that trust me, the people who have, I'm saying it with observation, right? Maybe this is 15th or 16th batch, whatever is it. So people who have finished and only just do this drill. You will see that you feel, acha, I can do everything. That feeling that is the only feeling I can generate out of this class. That the feeling to say this. Okay, I don't say that you will do it the best way. What I can say is, okay, you will continue to do this, right? So do this drill today. Okay, beat this problem. Okay, this problem is assuming whatever is done so far, or take the previously uploaded notes and all. Okay, then see how to get the result one. Just see execute this as a last line, accuracy score. That will shape it up. After that, there is no looking back. But if you don't do it now, then it will become difficult. Okay, so this is a humble request. So do it now today. Okay. So this point you were with me, right? Okay. After that, just copy paste this code, the pipeline code, right? You remember I wrote some of the 2-3 options last time. Fit. Just do it with one logistic regression first. Forget about other things. Okay. Just do it there. Then try to add one more and see how is the result. Compare the result. That's all is required.
With the original data set or just trained data?
Original data.
With original.
Whatever. I mean, how much time you have. If you don't want to do in this data set, that is fine. There are a lot of other data set like
no. Actually, we have filled age.
You have numbers and all that, right?
Yes.
Right.
So on top of it, we have.
On top of it, you apply. because for that also you need to convert into numbers, right? So just do this thing. Okay, a few things we actually jumped, maybe we could have done a little better. So what is that thing? First convert everything to numbers, then split the data, then do the other things. Okay, so that it becomes easy to do some of the operations.
First one is
Convert it. First do that unique things, those things to see, understand that actually this process will be much better if I use some unknown data. We'll go more on a systematic. We'll see that. Okay, we'll do that as well. Okay, because here there is a problem. If you remember something, then your mind is biased, right? Your brain also plays games with you, right? We know it. Acha, this is what it is. Okay, so you'll do better when you take up some unknown data. Okay, understood, right? The process part so far, it feels a little more confident, doable.
You just explain that after that break, right? You using linear regression, you predicted the age that is
Right.
So you get a number of days
Right.
and ages. So after that, the code wise, can you just explain like how you map it? I
Right.
understood what is to be done, but
See, the only two things. See, what you have after that, you have two data frames. The two different data frames have different indexes. How do you combine two data frames with different indexes? Using concat function, you can do that. Right? Or append function, you can do that.
in that one,
You have
Right.
now
you have
concatenated with the original data frame or
No. Only the converted data frame. Actually. Okay. See here.
see B is equal to age, something is there, right?
See this age thing, right? Yes.
No. And this is the age you work, right?
no data?
So let me do it from here. Execute it.
No, not here. Not here.
No, I understand. I just want to get the same variable names. So what you're doing, age train. I think this will work now. Yeah. Oh, age train is anyway not there. Oh, this one.
Okay.
Yeah.
Yeah, this one.
You just have to pass here. This is concat the two data frame. Right? They will add like this. Since you are giving x is equal to 1, like this. Understood, right? You can do this with append, not append. You can do this with there's one concat or
Join.
this is the simplest approach actually. Concat. You can do this with other things also.
If you do extract also,
There is one column stack. So you have all those options. This stack was not coming here. I don't know. But anyway, this is one option you can do that. Got it, right? So this notebook has everything.
Drop dot NA something is there. Age, train, and drop dot NA. What is it?
You can see?
B is equal to 7. After that, predicting a linear regression.
Oh,
Just after linear regression.
this one.
We got the ages.
Got the ages, huh?
The beginning one.
This one, huh? This is the state now, right?
Tell the number. That's some 7.
your number will be different.
Don't say.
Tell one line before or after.
No, you predicted the ages which is linear regression. Next step is you're just adding this linear regression to that one, right? To that.
The output you have the ages you calculated. Now this you have to append to the concat.
It is not null.
Concat, right?
So just concatenating you do.
See, you have a data. You finally found out all the data for which you have to predict. You found the corresponding ages for that, right? Then you combine with that missing, because that does not has age column null, right?
76 can go to 76 because I use 76.
See this one, right?
No. Yeah, that thing. B is equal to age train, drop dot NA, reset index.
Oh, this
operation do? Yeah.
No,
this
we
I'm not
haven't
using.
done this thing.
Yeah.
Oh, that's what I mean.
Okay. Till this. So all in all, what is the end output? End output is your all columns as numbers. All the rows are there, and wherever there was missing data,
We filled it for a train, yes, not the full set, right? So for full set, No, for training only we have all done, like age
Right.
replacement and this embarked filling, everything. Test we haven't done it.
Test we haven't. Test actually already had the missing data.
Okay.
See, if you just in a polished way, if you have to see this entire drill, right? What is the first step? Maybe I can write it down somewhere. Okay, first thing that you did was you of course you did data visualization. I mean data. You saw the data and all that. Then the first step that you are doing here is you are basically finding rows with valid age, right? Find split data into train and test. Okay, find that before that you do this, convert string into numbers. Okay, then split data into train and test, right? Then what is the fourth thing? After splitting the data into train and test, what you are doing? You are using train data, you are predicting the model. Predict the model using test data, validate the model. Okay, which we didn't do in this case, right? But this is the continuous flow. Okay, then what is the sixth? Okay, after finding the best algo, use that predict missing row edges. Fine. Now merge data frame with age and frame rate. Fine. Data frame with fine. Okay, after this get into classification.
In point 7 and 8, we have to use train or test.
Train and
Both, right? So we can do it in the initial stages.
Wait. Finding the best. So till finding the best algo, you will do and using the find the best algo. Okay, you used to do this. Using the best algo, you will find only the missing elements data, right?
Yes, that one. We have to do it with the original data set, right?
Yes. But in this case, we have.
No, I'm saying in general. Before splitting the data into train and test, how we are going to predict the age with train and test, and then we are going and merging it.
Right. So here you have this. You are predicting missing row ages, right? After that, you have a data frame with all numbers and missing row ages.
But that will be only for the train. See, our ultimate aim is to do the classification, right? We are not using train and test for regression only. We are using that for classification also.
Right.
So you have to do it in the first section.
No. Result the data now merge DF with age and DF with predicted age. This is your. This is to what you are adding. This is.
It's your original data, right?
Correct. For classification also, we should have a train and test also, right?
Wait. You have this is one data frame, right? Where it has all the data converted to numbers, right? So at this point, what should happen is the same number of data should be there, just that the missing age thing should be replaced with the actual age. Fine, right? Did anything mean something different here? Now merged.
Now we have to once again split it up train and test, right? Because
You can
we have a new kind of data, right? Presently, after line number 8, we have a new kind of data.
You can do that. Okay, I can do that. So what would I write? Result is data frame with no missing edge. So this is like complete.
Complete.
Yeah, so let's write complete.
Complete data.
Complete data with no missing edge, right?
Yeah.
Okay. Now this is like, now after this is like a new problem.
One second,
Getting into classification. Oh, sorry. Get back. Okay, now we'll repeat the same process. Just that all data is in, okay. Train, test, split. Okay. Then what will you do? You will create, data is already transformed. You don't have to bother much. Okay, you just create pipeline now. Okay, with different algorithms. Okay, so how will you do so? You will, okay. Or for this is almost this part we have, till this point we have done, right? Almost this point. So this is what you have to do here. So first is use logistic regression and find the survival thing. Okay, use your accuracy functions to find accuracy of it. Second thing is use naive Bayes, right? Right, this is all, and see, use accuracy to find out which one is better. Then I'm saving it here only.
So doing chatbots and NLP is different.
NLP, deep learning.
Self-learned is not it.
Very basic one you'll get, not so advanced ones. Okay, so I have a few problems. If somebody. Yeah, I think
Still not yet uploaded.
this one, right? The same thing. Project 6. Yeah.
The steps are also inside this one.
Yeah. That is there in Wiki. Wiki. This project data science, right? Wiki. So here there are a few problems also. You guys will be solving this. Predicting which year of song is it.
You have saved that and uploaded this one. This 6.
It is saved and uploaded.
The last one not done.
Okay. Let me do that in case. I'll do that now. So these are the problems that we'll do. The fresh problems we'll do to your batch. Okay, like every batch, whatever I'm data entering, it's the previous batch problem. So here we'll be predicting year of song from release with the different parameters. Second, predicting number of comments a blog will receive. Okay, income prediction. I hope nobody applies on me. Huh?
I'm not going to go with that income prediction.
What?
Something interesting.
Why income is not interesting?
You know it is interesting.
We know the market one.
Then one is food review. Anyway, we have seen a little bit, and Titanic. This is what we started with.
They will predict and marry.
Okay, so this is supervised ones. Unsupervised, I will mention few things later.
Unsupervised theory we didn't cover.
No, we didn't reach. We want to start unsupervised tomorrow. No, not me. Others will kill you.
Supervised only, we are still unsupervised space.
Actually, unsupervised ones are easier. Confusion matrix. Okay, let's see.
The coordinates I didn't understand.
Okay, let me show one confusion matrix.
What is it and when it is?
Confusion matrix is a classification. In this case also, right? You can print confusion matrix. So let me show now.
Where you uploaded that points which you have
Huh?
the points which you type, right?
It is there in wiki. All the notes. Wiki project Titanic dataset.
Send this link.
This is wiki. Just click on the wiki. You'll find all
On
the.
the right side,
I'm about to restructure. I think next month I'll do this. Restructure the entire thing because a lot of code writing has happened. Like 5-6 batches I'm following this stuff. So I'll just consider it and I'll share it with everybody in the book format. Huh?
It's downloaded. In between it's stopped because the connection.
There is confusion matrix. The objective of confusion matrix is to get rid of confusion. The objective of confusion matrix is to get rid of confusion. Okay.
The last class.
See,
I don't understand this graph.
Yeah.
which one? This. See, graph is actually
What do you mean on
this one.
Yeah.
This is same. This one you understood.
No.
Then how can you understand? Okay. Let's see. So this is a case for classification. So you understood few things, right? How to find accuracy of regression algorithms, R2 square, mean square error. You know which page to check. Right? Just Google search sklearn matrices accuracy linear regression. You will get scikit-learn library. It will show 4-5 options are there. Okay. R2 square, which is like between 0 and 1, mean square, all those things are there. Similarly, for classification, there are also similar to this. One of them is confusion matrix. Okay, it gives you a very good insight what is happening. In confusion matrix, okay, see this data. This is the target data, test target. This is the labels, right? That means this is the prediction. So this is the prediction. This is the actual information. Right? You are comparing it here. And when you are comparing, this is a classification where there are 5 classes. No. There are 5 classes. This is the classification. The 5 classes are there. You can see this is one class, this is one class, this is one class, this is one class, one class. This is the same things repeated here. Okay. Okay. See this. This is true level. This is predicted level. Okay. The diagonal thing means. Okay. This is written computer graphics. Okay. This is computer graphics. Okay, and this is computer graphics. It means 360 actual computer graphics were predicted to be computer graphics. Diagonal thing means miscellaneous for sale means miscellaneous for sale. Diagonal is the correct entries. Okay, the things below it and above it are misclassification. Okay, and if you have to understand it little more, what does it mean?
No, actually,
computer graphics, the actual computer graphics data which are predicted to be size space is 13.
Yes.
Right, that's
13 times.
13 times it was wrongly classified. That is how you should read and understand it. The way of plotting it is also simple. Actually, you have to use heat map. Generally, pretty much standard code for this thing, this confusion matrix, heat map.
Whatever I have come across, in them they divided the confusion matrix into 4 quadrants.
No. That is because there are only 2 classes. That is the 4 quadrants. For 2 classes, there will be 4 quadrants, right?
True, false.
Right. So this is much more generalized. When you have multiple classes, it means that this is true. All the others are false.
Yes.
Means 13 mismatches you said, right?
13 is not mismatches. Computer graphics were 13ly wrongly identified as space.
Wrongly classified
as space. This guy, computer graphics was wrongly classified as Christian.
And the other side is finally classification.
No, only diagonal is correct. Other side is reverse also, right? Whatever is this is wrongly classified into computer graphics, isn't it?
Not a single time it's classified correctly.
No, it is 60%. This is a heat map.
Always go diagonal.
Yes.
Always go diagonal.
Always diagonal is this, is that? This and matching this. So diagonal will always give you true information.
So I was saying like it's math plot like okay. When we will be having a session.
We can have a session maybe tomorrow or maybe next. But because of that, nothing is blocked. We'll have it. We'll have it. We'll have it once. Just that as a flow, before we get into more problem solving mode, I'll do that.
I just clubbed up with them for 2 sessions.
2 sessions.
I and another person came on Saturday and we were on leave.
Oh.
So we just I just sat for up to scatter plot.
Achha. Oh, somebody else was taking, right? Okay. We'll plan it. Okay, maybe tomorrow itself after the class. Yeah, whoever has missed out, Matplotlib, right? Tomorrow, I think after this class, last night to take the session.
No, it was not fully done.
For you guys also. Right.
Basic solution.
One thing. Even I also not
a few things more. Actually, Matplotlib is more of a how to use it. Few things you need.
1 hour class.
1 hour class. 1 more hour is required, and then 2 hours is decent enough for visualizations. Okay. And there are a few things like plotting. Like in this case, this is a standard way to plot it. The heat map. Right? Then you have something like bar charts. So the 2 things. One is bar graphs. Maybe tomorrow class itself I will also itself take, or maybe we'll plan it.
Avantik. Hello.
Okay, we'll end the session.
Avantik. Hello, Avantik.
How do we download only one file from
I tried. I don't know. I don't think there is a way out. All you can do is you can continuously sync it, like fork this file, and you can update it. That's all.
Or I have to download everything.
That is not the way. You fork it.
You can download full and just.
That's
Hello.